Hello, guys. Um, I'm Gabby. Um, I'm going to be talking today about what it means to have a device that's vulnerable by design. And going to go into great lengths about that. I'm just going to do a short intro about myself and about my brainchild in the latest year. Um, For those of you who don't know me, some people call me the public transportation hacker. That's because at some point in my past, I managed to do a simple MeFare hack. Um, Heard the talk about Black Hat, I think, about the vulnerability of MeFare classic cards. Decided to apply it and did a responsible disclosure to the CERT in Romania and to the guys that were responsible for implementing the system, and it turned out to be a really successful story. After that, they patched the system, and I found out that I couldn't get any more free travel anywhere, so I decided to hack my car. Unfortunately, I wasn't able to make it run for free just by pouring water into it. I found out, though, that it knew a lot more about me than I actually knew about myself as a human. So that turned out to be a pretty cool stunt. Um, while exploring the security field, being quite a newbie, I decided to go around and try to just give back to the community as I was learning more and more interesting stuff. That's when I decided to just make the internet more secure and do that more explicitly by hunting for bots in general. I mean, not everybody in Romania gets really proud about making robots, you know. That's when I got hired at White Ops, and we decided to go full throttle into our bot hunting ordeal. And the easiest way to do that, because bots don't really get the chance to profile their target, would be just to sprinkle around honeypots in various places around the internet and just hope that they launch their payloads to you as well as their vulnerable victims. And I mean, I needed to hunt for a platform that had readily available devices that would run an operating system on anything. So even if you have like 15 and 12 megabytes of RAM or something like that, or 2 gigabytes of RAM, you would be able to run that operating system. And that operating system turned out to be one that's deployed on smart TVs, smart fridges, smart toasters, smart cars, and even smarter toasters. Let's hope that we won't get there. And it's called Android. We have more and more and more Android devices that are being used in ways that Android shouldn't be used, I guess. I think 2 years ago, Kevin Beaumont made a really cool story about how a lot of these devices had a certain port open on the internet. Now, who around here is an Android developer, or at least compiled some Android code at some point in their life? Okay, who uses Android? All right, represent. So the trouble is that Android has a certain port that can be exposed by just running a simple command via USB. It has authentication initially when you launch it via USB, but that's when things get really messy. So I just started working around, tinkering, trying to get the creative juices flowing. I wanted to build a simple honeypot that would allow me to connect the device, to emulate pushing binaries to the device, so an attacker would be able to send his payload to me, and me to be able to analyze the said payload, just in order to do some simple reversing and stuff like that. And most importantly, to get any shell commands being sent my way, because this is the main attack vector that we see nowadays. You just have, for example, I don't know, but there were a bunch of botnets that would just connect to any SSH-enabled device with default credentials and just spray commands and just have its way after that because it just had admin access. There's a lot of documentation. I won't go into any more detail about that. The problem is that most of it is not up to date. ADB was initially designed as a simple protocol to just multiplex streams. So you would be able to open a shell stream and send commands, and you would be able to do more and more, to connect more devices, and they added more streams, and they wanted to also be able to push files, so they just bolted on more stuff onto it. And it got to a certain point where you can't get really solid documentation about that. It has a few interesting details that you can find on the internet. Initially, you could just send a command. You'd have 2 arguments to the command that you can use. Some extra stuff that would be used to check the integrity of the packet. The commands would be really simple to interpret. You've got a sync, connect, authenticate, open, okay, close, write. Anyway, boring stuff. I mean, and there was a bit of decent research done by my previous peers before. Basically, if you want to open like a shell stream to your device, you just have to send an open, you would get an OK, and then you would get a write with the results of that command. So initially, it was pretty simple. And I said, oh, yeah, I can definitely do that. Let's give it a shot. And it didn't work. I mean, that's one of my cats. She's awesome. She's part of the reason I'm here nowadays, because I wouldn't be able to just reverse engineer the protocol without the help from her and my girlfriend as well, who just supported me in these endless nights of just bashing around and just brute forcing my way around that. So let's give them a round of applause, please. All right. And that's when things got really nasty. It wasn't a simple CRC. Fortunately, I found some guys that are way smarter than me and reverse engineered that. There's also some data packet that gets appended to the end of the packet, and I found out that that was a industry standard, no matter how hard that would be to document. I don't know why that happened. It's just by design. As I've said, I guess I did bet 10 pounds of the Queen's finest that just a project manager came in one day, hey guys, we really need to get this feature working, so let's get to work. And of course, you know, the first thing that you sacrifice when you're out of time and money is security. So yeah, we've got the aliens backdooring us. This is the same command being sent 3 times. Notice the differences. It's literally the same command, the same network, connectivity, features, everything, but I would be getting different responses every time. So initially, I would implement it in a certain way, discover that it would work, and oh yeah, I fixed it. And then the next day, I would get a totally different network flow. And then I would say, oh yeah, I'm so dumb. Why didn't I do it like this the first time? And I would implement it using the second flow, but it no longer worked for the first flow. So I would basically just have to map everything down. This is gonna be, I'm not gonna go into length about that. If you want to do your own implementation, feel free to do it. This part, at least, of the slides are gonna be available online after that. You can already find this version of the slides somewhere on the internet, so don't worry about it. You don't have to take any pictures, especially like, unless you have a Huawei. Those go like zoom so much. They're designed for surveillance. So yeah, so just map the flows one by one using a piece of paper and a pen, just like all times. And it still didn't work. It was so weird. I had to get a lot of help from the open source community into getting the packet structure nailed down, into just experimenting over and over using various network topologies, and just brute force it. There's no easy answer. There is no shortcut to just hard work and just mindlessly delving into a rabbit hole in the hopes that you're gonna fix it, because it's just faith that fuels you at the end of the day. And it worked. I was able to connect to the device and all of the stuff that I set as my goals initially. And we'll actually have a live demo right now to just illustrate the whole point. So you have the honeypot. No, you don't have the honeypot. Hang on a second. There we go. So we've got the honeypot running right now. And let's connect to it. We've got a connection. Yay! We can push a file, and we have it right here. It gets hashed, everything. There was a lot of work being done by third-party, by some other researchers that were so kind to me to just fix a lot of the bugs that I introduced and give it Docker support, Python 3 support, and all that. So kudos to them. Thank you, guys. You've been really kind. Let's keep it going, and let's just make the internet a safer place. And what's really cool is that you can actually do any kind of shell command. And the shell command is right here. Bam, it's been caught successfully. So now I have a honeypot. What do we do with it? Well, we catch malware. And this is going to be the second part of the presentation, in which we'll go into all of the strains of malware that I have discovered over the past year. And the first one that hit my honeypot, initially I thought it was a good Samaritan that would just kill all of the other bots and hopefully leave it like that, except it didn't. It would also push its own APK that would start mining on your own device. So, you know, he was just basically undercutting his competition, trying to get more CPU cycles going. Now, this guy was a visionary. He was the first one to actually do this kind of stuff on ADB, just kill off the competition and try to run. Now, two more emerging threats were really cool because they actually ended up competing with each other, and there was actually a story about it. And the first one is Trinity. Trinity was composed of a three-part payload. The first part of the payload was just being sent via ADB shell, as bootstrapping the other parts. It would send an APK that would do mining inside the APK. It would send, and after that, it would send a binary that would do the worming part. So it's basically just a worm that would propagate around the internet freely. And when disassembling the APK, this was done using JADEX, by the way. I definitely recommend it to anybody who wants to do reverse engineering into Android. It's a really free open source tool, very cool, well maintained, and it gets you readable code. So especially if you've done a bit of Android, let's call it hacking, because I'm not a developer, I'm a very bad developer, to be honest. It gets you to the point where you don't read any kind of bytecode and you can read code. And if you look at it, this would instantiate a web view. It would, in the web view, it would load an HTML file, and inside the HTML file, it would just parse some coin hive JavaScript and just call it a day. You know, you've got mining. But this only works for one device. How do you propagate to all of the other devices? And that's where when the worm comes in. The worm was a binary that ran explicitly on Amazon Fire TVs. It would scan over the internet and then check if it was up, like every part of itself, the wormable part and the mining part, and restart or repush the binary and so on and so forth. So this guy was pretty well off. He had a stable botnet running. I think it had like a 10% infection rate out of a 50,000 devices pool, so like 5,000 devices just running for him, just mining for him at some point, some really easy cache to rake in. Until FBot came in. And FBot was a really cool piece of work. It just started as a shell payload that would download the second stages, and it actually had a blockchain DNS system. Like, you know, the bad guys are learning all of the buzzwords. Soon enough, they're gonna do like machine learning as well and other stuff. And this is part of the second stage of the payload, where it would download the binary and, of course, uninstall the competition. This is Trinity, by the way. And they actually ended up being the biggest competitors on the market. And I do not recall the name, unfortunately, but somebody did a really cool job on just documenting this constant shift of power between the two botnets fighting with each other. Now, there are also some small-time guys that I've only seen just a couple of times. This guy was really interesting. I guess he just finished some kind of tutorial on the internet about how you can encode payloads, and he figured out, oh yeah, we can do this, except you can't because ADB is very bad, and sometimes you'd end up with the instructions getting out of order and just screw up the payload, basically. You've also got, not this guy, Putin helper. I don't know if you guys can read, but it's actually run that. It's a DVR, it's a botnet that was exploiting DVR devices. It was called Putin helper by some reason, I don't know. That would also do mining, because this seems to be the gold mine of the malware guys are exploiting nowadays. And the last one, and the funniest one, and was found by a really good friend of mine, Stefan Tanase. He actually apologizes for mining on the device. I mean, let's not feel sorry for him, but it's so hard. So for whoever can't read that, I'm sorry, but I'm mining on your device, not because I want, but because I need the cache. I'm truly sorry, but currently I can't find or get any job, so I have to resort to my black hat way in order to survive. So he actually asks for a position, and he can provide you as a CV, and you'll end up in quite an exclusive club where you get to be whitelisted, and he'll no longer be mining on your device. So yeah, funny for him. I mean, sucks to be him, but you know, you have no excuse in doing this kind of stuff, you know. And now the really, 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 really bad part of this whole story comes in. I'm gonna please ask you not to take photos of any IPs or any real humans that are gonna be shown in the next slides, because most of them were IPs from South Korea, Taiwan, and Hong Kong, China's neighbors, you know? And they seem to be like actual people. No TVs, no nothing. Just phones that at some point were compromised, and somebody was just watching over them. This is a huge list. The list goes on over and over and over again about the versions that are available for exploitation over there. And I would get into this huge debate when I would show these slides in other conferences about the fact, oh no, man, you can, if you connect your USB cable, it asks you for authorization. And I guess it's the same if you do ADB, TCP/IP. No, it's not. This is like you've got even Android 9 that's being exploited out in the wild. And there's no authorization whatsoever when it comes to doing ADB, TCP/IP connections to a device. So this is out there, it's in the wild, anybody can exploit them. Please don't, because you end up with like really serious consequences. And let's say that I had some sources that were able to just do a bit of recon, and you can easily connect. You would find all of the bad guys that I'm telling you about. Trinity, some random miner, the FBOT stuff, Android 6, so it's, or 5.2, I can't recall. And this is some other device that had Android 7. So this is being exploited in the wild, and people are building botnets of it as we speak in the wild. And from now then, we're gonna see some pictures of real humans. So no pictures, that includes you, Dad. Thank you. So let's go. This is a guy from the Air Force system in Taiwan that had a TV with an exposed interface. I can imagine a five-star general just watching his porn over there and some other guy spying on him. Fortunately, in Russia, they got it nailed down. Oh, shit. Skynet is learning a lot of new stuff. We don't want it to run in Russia, so let's see. And we at White Ops usually play a certain game called Bot or Not, that we just look at metadata about certain, I don't know, interesting artifacts and try to decide if it's a bot or if it's a human that is doing that. Now, I'm gonna do it interactively with you guys, and we're gonna play backdoor and just make the world a safer place. So this is what I did. I open sourced everything and got memes in exchange. These are mine. These were made by some really cool Bulgarian guy who contributed a lot to the honeypot. The amount of vulnerable devices dropped from 50K when I started doing it to about 10K, then to 8,000, but recently it started going back up to 12,000. So I guess those engineers somehow said, you know what, it's way easier to just open that port up and automatically test all of our devices that we ship on the factory. And this kind of reflects in the stats that I've been getting. I don't know about you guys, I'm not that much of a statistics guy, but when the graph is like this, it's boring. But when it's like this, it starts getting really interesting. And I started digging down a bit more. And let's see if we can spot the anomaly. Somebody was pushing a lot of uploads and building a botnet, just here, somewhere in June. And I dug a bit more into this, and I discovered that after the community pushed back a bit, he kind of reprofilated, and he decided to just use one big data center that he would just burn from now and then, and just send shell commands to mine, because this is the nowadays gold mine that everybody's exploiting. And he was doing exactly the same thing as everybody else, spraying over the internet. Fortunately, he got a lot of abuses from other researchers reporting this and going around, hey man, that's bad, stop doing that, you're bad, you shouldn't be doing that. And he was taken down very fast, very, very, very fast. The honeypot got added to the Teapot project, again, by some really cool dudes. Everybody who runs Teapot right now can get it working really fast. You can even get it running just by yourself, by just getting the Docker if you're that kind of guy, and pushing it over there. Every feature it just works. I'm still pushing more and more stuff to it. Just go to my GitHub, you're gonna find it there, you're gonna find all of the documentation there. I'm gonna do the Python 3 integration these days. I've already got the pull request, checked it, everything is done. I'm validating it as we speak. I'm like 95% done. I just need to do like one minor fix. But check it out on GitHub, and check me on Twitter as well, because that's where I post all of the cool memes as well. And I don't know, I guess, looking back at the other slides, I guess it's just our duty as researchers to do the right thing and push back whenever we find any kind of threat, and not just whine around that, hey man, this is bad. So thank you, and keep the internet human.
Are there any questions? Keep your hand up.
I've seen that some of the devices that you presented on the slides are mostly located in Asia, where the Google Play services are not that common, at least in Hong Kong, as far as I know. How many of the devices which you presented do you expect have passed the Google CTS?
The Google, sorry?
The compatibility test suite, which also has some security requirements.
I think that not a lot of them. That whole part of the world is just one special snowflake that's kind of more like the Wild West. So I don't think that there had any kind of intersection with anything that Google represents. So yeah, I would guess that the compatibility test would go really well. What I can say is that there are a lot of older devices that have all of the hackers' best tools. So you've got NetHack, you've got wget, you've got curl, you've got everything pre-installed on them, I guess for testing purposes. And they just forget, or the manufacturers didn't bother in removing the staging build, the test build, and just putting a production build on there.
More questions on that side?
It works, okay. So at some point you presented the list of IPs saying, there's tons of them. I'm thinking they're still open. I guess anybody can find that out. But you said at some point that some of the malware tried to kill the other malware that's already installed. I assume they already have root on that device, as in if they get ADB on. Have you ever met a malware that tries to fix the issue and only allow itself? Why not?
No, I haven't
Okay.
seen any kind of malware that would try to just fix the issue, mostly because even if you try to fix the issue, you have to shut down ADB, and you can shut down ADB with some kind of exploit as well, and that's a big, I mean, it's not that hard. Most of them are old Android devices, and there's a lot of rootkits that just work out of the box. But it's a bit more effort than just going around killing them and closing the port as you would have with other botnets, for example, like Mirai and stuff like that.
All right, any more questions?
In order for you to have access to ADB, shouldn't you enable debugging, you know? So most of these devices already have debugging on. Are you?
Yes, they
Really?
are vulnerable by design.
But by design, they come with debugging off. So how?
No, because it's the manufacturer who implements the design. Android by default has ADB off, right? So I figured that there's somehow some test lead that just figured out that you can just ship the build with ADB open, connect the TV or whatever to the to the test Wi-Fi, push all of the test APKs to the device, and just get a cool panel like to detect dead pixels. Or it's just wild speculation, but this is what I think that they're doing.
What would be your recommendation for us to do in order for us to protect ourselves? Maybe
Well, check if ADB is open.
that's it?
Yeah.
Anything else? Oh, okay.
That's it. Android is fairly transparent when it comes to that. You can check it really easily. Just go like in developer options and check if it's open. If it's not open, then most probably you don't have anything to worry about.
All right, let's take one more.
Thank you for the presentation. You talk about ADB was open, but what about the process isolation that was present within the Android system? So even if the ADB is open, if you don't have the root privilege, you can't access the other resources. So are you talking like the ADB is open and you can escalate your privilege to access those resources like
Sorry?
The ADB is open and you can escalate the privilege and gain
Yeah.
access to the resources like?
Yeah.
Okay.
There were some devices that came out pre-rooted. I don't know why. I guess easier testing. But most of them were locked down. There's also a bunch of emulators out there and a lot of the honeypots deployed by those really awesome guys who just got into this.
Thank you.
All right, thank you, Gabi.
Thank you.